please welcome on stage Antonio, the VP of Product with Polyhedra. We have Roshan, the researcher and Marlin. And we have Shuyao, who's the head of global business development with Linea. Cecilia, who's the ZK engineer at Taiko. We have Paul, who's the co-founder of OpenBlock Labs. Last but not least, Kenny, who is the co-founder of Manta.
All right, cool. Let's get started here. Very huge panel here talking about the benefits of ZK. So let's first get started from a round of introduction. Guess I'll start from myself. So I'm Antonio, the VP product of Polyhedra, where we provide the interoperability using ZKP algorithm, where we build a trustless and efficient cross-chain protocol, what we call ZK Bridge. And that's one of the reasons I'm moderating today, since ZK Bridge provides full interoperability for all the projects here.
Okay, so my name is Cecilia. I'm a ZK core dev at the Taiko Labs. So Taiko is a layer 2 type 1 ZK EVM. So we features a permissionless protocols for block proposing and proving, and also for the ZK EVM technology itself. We have this type 1 premise that we need to we try to fulfill, and in our current testnet, we're really trying to battle test the robustness of our protocol and really ensure that the proposing and proving are permissionless. And comparing to the other layer 2s who are beefing about their ZK technology, we're trying to provide like an overall robust protocol itself for everything to work. Yeah, so we're pursuing multi-proof system.
Yeah, I love dev people coming onto the stage talking about hardcore technology.
Hey, I'm Roshan from Marlin. So I'm a researcher there, and we're working on building a proof market for like projects who are currently probably generating ZK processing on their own or on their like users' devices. So it's sort of outsource that to us, and we'll ensure it gets done like much more efficiently, faster, and cheaper for our device. That's what we're doing.
Yeah, we love proof generation market. Actually, I don't know if you read before. We have a paper recently published for decentralized proof generation. Should have read it.
Hey guys, I'm Shuyao. I am not a researcher nor an engineer, and I'm not even technical. I'm your definitional business person. I lead global business development at Consensus. We have MetaMask, Impera, and now new ZK EVM layer 2 called Linea. It is completely EVM compatible, so all the tools and infrastructure you love, you can migrate your dApps directly onto Linea and get the full support from Consensus. And thank you for inviting me here.
And thank you. This is Consensus.
Hi everyone, my name is Paul. I'm one of the co-founders of OpenBlock Labs. OpenBlock is a data intelligence platform that helps protocols make informed decisions in a data-driven way about growth. Most recently, we've been leveraging zero-knowledge proofs to help make some of the data intelligence insights verifiable and chain.
Awesome.
Hey guys, I'm Jennifer from Manta Network. So basically, we are layer 2 as well, and we use ZK to build the integration circuits for enabling more game applications to be fully on-chain. And instead of that, because we partner with Cecilia, so we have the much lower gas fee than other layer 2s. That would be one of our advantages as well. And welcome any dApp to contact me, so we can talk about what kind of the support that we can provide.
Thank you. Well, I'm a huge fan of game. Looking forward to more web-created games. All right. So since our panel is entitled "The Benefits of ZK," so the first question falls: what is the benefit of ZK? In terms of your project, why do you choose to go into the field of ZK in the first place? And what does ZK bring? What is the thing that you can do with ZK, exclusive with ZK, but not other technologies?
Okay, so
Since we're layer 2, I guess our goal is to scale Ethereum, right? And in order to do that, as everyone knows, like blockchain has this like trilemma of like scalability, security, and some other things. Decentralization, yes, thank you. Yeah, and like by the theory of consensus, such things cannot be achieved. So we've been through these like L1 battles several years ago where we realized all these premises can't just be achieved by like faster P2P network or whatever. And that's where cryptography comes in. And that's why when Ethereum is implementing this like these scaling strategies, we choose ZK. And I'm not saying that like I'm not going back to that argument between optimistic rollup and ZK rollup, but I do believe that eventually, even in Vitalik's roadmap, they're gonna snarkify everything at the end game of Ethereum. So I think that's why ZK is at the core of scaling Ethereum and the rollup technology. And for our project, which is Taiko, because we try to be type 1, and that requires to execute all of the Ethereum block as it is without changing anything and prove the execution. So we require very performant ZK technologies. Yeah, so we're awaiting this industry to evolve into its next stage to accept like even higher amount of block transaction and even more computation itself. So yeah, looking forward to more like ZK advancement.
So to elaborate on the scalability front, like ZK Tech basically gives you like what I like to call computational leverage. So essentially, let's say you have like one prover and one verifier doing some work. I will like they basically are sharing the work now. But let's say now you have one prover and like 1,000 verifiers, right? If you can make the verifiers do half the work, you can make your prover do almost like 500 times the work, and it will still all work out in favor of ZK Pros at the end. So this sort of leverage is like very valuable in the blockchain space because you have one person creating a transaction, but you have like thousands of people verifying it. Right? So yeah, that's basically the most interesting part of nice.
That was a really good crash course in what ZK does. I need to copy that. It's the computation leverage. I think we're at the very early stage of exploring what zero-knowledge technology can do to our industry, and honestly, I think to the world. When we started Linea, we're actually using ZK for privacy. So many people didn't know 3 years ago when we started Linea, it wasn't called Linea, it was like called Yola. We gave a name Asumo because we're using ZK for privacy. And then we realized that holy moly, you can use ZK for scaling as well. And I think we're going to have multiple stages of like, hey, you can use ZK for this and ZK for that. The question I think we should consider even as an infrastructure player is like, how do we fit ZK into specific use cases, right? Like, I know Manta Network, you guys are doing a dating dev using ZK to like cover your basic information. That to me is really cool. Like, I don't think people need to understand computing, but if you understand, I don't know, you go on Tinder, hey, I'm not. And he walks in with me talking about Tinder. Great. And you don't have to reveal information. That to me is more interesting than like what ZK technology is. So to me, it's really about the application.
Yeah, so for a bit of context at OpenBlock Labs, we help protocols reach something we call optimum complexity, which is the minimum amount of information you need to make a well-informed decision. And over the past few years, we've been seeing that protocols are getting more and more complex in terms of the amount of decisions they're making and the number of decisions. And most of these decisions require kind of pushing the intelligence out to the edges of the network, which means relying on service providers, relying on tools like Dune and Flipside for data analytics, and other kind of data intelligence products like OpenBlock Labs. And what that kind of does is it makes a centralization force, where you start relying on the centralization of these service providers and these tools, and you put your trust in them. So what we're trying to leverage zero knowledge for is flipping that and making these tools trust minimized and helping DAO scale and make decisions about growth while still maintaining that decentralization.
For Manta, I think we are more focused on different use cases. Like right now, we have developed the DK like infrastructure tools for our ecosystem called universal circuits. So basically, we have different categories of the DK tools for the developers to just call API. They don't need to develop the circuits for themselves, just by themselves, but they only can, like, they will be enabled as a DK function only by calling the API which we have provided. So for the categories right now, we can enable the game application to generate the randomness, which can enable them be fully decentralized and fully on-chain. And also, like we have the function for the like to enable anonymous vote, that kind of stuff. And just for the use cases, for the layer 2 that we're building right now, besides of the fully EVM compatible function that we are providing, we also welcome more ZK applications to leverage the universal circuits we have developed for like 2 years. That will be our huge advantage for applications, like whether they want to choose to deploy on Manta as well.
Yeah, thank you. So I love all the proposition here. We have scalability, we have privacy, we have interoperability. We build this infrastructure for all our users. So as we were talking about the other panel the other day, so we have a lot of infrastructures in the space. But at the end of the day, infrastructures needs to be used by applications, needs to be used by end users. So the next question falls in. Well, we talked about how ZK benefits your project. What can you do with ZK? The next question is, what can user achieve with ZK? With adding the ZK technology, what changed? What's the difference in user experience from the application level, for end user level? What can they do with ZK now?
I think in general, the idea of ZK is to let enable users to delegate trust to mathematics instead of to any centralized entities or even decentralized entities, right? Like if I am an Ethereum user, I delegate my trust to Ethereum based on the fact that it has trillions of millions of validators, right? But a possibility is the chain can rework, right? The validator can go down, right? The chain sometimes, blockchain itself can't even be trusted, right? And that's when we need even stronger cryptographic premises. And that's where ZK comes in. So with ZK, it doesn't really matter if what me as a user facing is centralized or decentralized or not. So I'm facing like a service provider that provides me certain API or certain computational services. And I delegate my trust and I delegate my computation to those entities, no matter who that is, as long as they can provide me with a proof. And I can verify that proof with like constant rounds of computation. I think like trust is one aspect, and a second aspect is computation itself. So with the shift of trust, I'll be able to shift my computation anywhere I want. For example, if I run a very low performance laptop, I'm not able to run some function that is too complicated. So I ask for like AWS for service. And I also at the same time ask for a proof at which I want AWS to provide me a proof at which like it correctly computes something that I expected. I think like in the future, this idea of shifting computation is very important because as we go on, computation become more and more powerful, essential, but more crucial in terms of security. And this modular design of like how people place their computational resources is emerging here and there around the world as well. Like we see how we see data centers and all that stuff. So I think with a universal application of ZK, we'll see the next generation of human computation be like all distributed and modular, and delegate it anywhere that you want, but with proofs, but with trust.
Yeah, also imagine one day you can use your phone to generate a proof for Ethereum.
So, one thing I'm really looking forward to is like a new generation of services that actually respect local privacy. That just kind of doesn't exist today. Right? And a lot of it is because like the only way to really do computation without ZK is by actually doing the computation yourself. Right? That basically means that you need all the inputs, you need all the data that goes into it. But ZK basically allows me to sort of hide stuff that I don't want to show to everybody else and still be able to prove that I satisfy some conditions. So it kind of covers both of our bases in the sense that I'm not revealing any data, but the other party also has like a verifiable proof that I'm not lying to it. Right? So yeah, I'm looking forward to like the next generation of what comes out of it.
Everyone's forced to be honest, they cannot lie with the proofs.
I struggle to answer this question because I think ZK technology will be commoditized one day if it's not already, and it needs to be omnipresent everywhere. There's going to be more use cases. And from a user perspective, I think Cecilia really nailed it. I think it is that fundamental level of trust of why we're all here. The real reason I struggle is I have not seen like a killer DApp that uses ZK without users actually knowing they're using ZK. Because the user cannot know they're using ZK. You lose them the moment they have to read zero knowledge. So I think we're just really early. I think next year, at the same time, there's like 1 or 2 killer DApp coming out. I think we've made it.
Yeah, great. Users should be zero knowledge about zero knowledge, and that's the thing.
Yeah, I think for us, zero knowledge is one of the only viable paths forward for kind of maintaining decentralization within a DAO. But I think there are 2 main blockers for that. The first is the principal agent problem, where you kind of have the DAO itself that is kind of an entity that cares about decentralization, and then you have all the community members inside of it, the token holders inside of it, who care more about maybe short-term monetary gain or reaching short-term KPIs that they have to go and progress towards. And then the second one is that when you haven't had a crisis moment yet, and I think a lot of crypto kind of watches for these crisis moments, like one DAO blows up because there's a big centralization issue and relying on specific service providers that change the parameters in the correct way causes a protocol to achieve like a erroneous path forward. And I think that crisis moment hasn't happened, and until you have leading protocols that are taking charge and leveraging zero knowledge first and then the rest follow, I don't think we'll even get there.
For us, because we have developed a few products like regarding to the decay, so for the user perspective, I think I can give some examples based on the different products that we have like developed before, or some ecosystem projects that we have like really focused on. The first product will be we have developed a ZKSBT platform called NPO. So what we do with NPO is basically like we enable the users. They have like maybe they have already passed some KYC, like maybe from Binance or from other like providers, KYC providers as well. And what they can do is that when they mint the KSBT, then they can only like have the KSBT without to provide their personal information or even their addresses, but we still know like they have the authority to do like some kind of things. That will be the first example. And the second example will be we have an ecosystem project who is doing the Texas Hold'em game project on chain, and that can make that game like fully decentralized. In the Web2, the Texas Hold'em, basically the game doesn't have like basically the game publisher or the game like developer, they know like what cards you have, but that will maybe like you can't trust them because that will impact like basically the final results of your game. So that would be a very good use case for the user perspective as well, because you can like have some game which maybe you can win many money on it, but with the fully decentralized and fully on chain, and that will make sure that you know the result is right. I think that is a good example for this.
Yeah, awesome. I love ZK getting ZK for imperfect information knowledge. One day I can play StarCraft on chain. All right. So here's the last question. It's more of an open-ended one. So we have all those developments of ZK into all different directions, into like privacy, into scalability, into interoperability. So what do you see the trend of ZK going? What is the future of ZK? How do you imagine yourself in that future? Or maybe share a roadmap in the future ZK development?
As a ZK dev myself, I have a lot to speak to this. So first of all, the tool chain of zero knowledge proofs is certainly incomplete. People are taking a million ways of different approach. For example, some people develop DSL, which means like domain specific language, while the other writes zero knowledge circuits as if it's assembly code, meaning filling out polynomial from scratch and compile that into a proof. And I would say this process echoes back to like the evolvement of like computer languages and operating system itself. So I think of like writing zero knowledge circuits as if we're writing like FPGA for special purpose computation. And later on, like the general purpose Turing complete computation will be done in solutions such as RISC-0 or like an intermediate language such as like DSL, Circoms or Snarky.js, something like that. But I think we're still like pretty far in the game at which all these possibility remains open, and I don't think any of it would die in the near future. But certainly they will serve for different special computational purpose. For example, if we want to like verify K-check computation for Ethereum, then we may as well use a special purpose chip implementation for that. However, if it's some like DEX protocol trying to implement some like swap business logic, you may as well just write a DSL, which is like fast enough. And in the future, I believe we will develop mature enough like compiler technology to compile simple Turing complete logic into performant circuits. Yeah. So I don't know. I think this process is like seeing how chip making industry or like programming language industry develop again. Like like when it goes back to its early primitive stage and then evolve again in this ZK landscape. Yeah, so I think it's very interesting to see how it grows.
Hope everyone understands what's the point there, but there's still a long way for us to involve in the ZK industry without those potential hardware acceleration and algorithm level optimization. So ZK is just getting started.
So, yeah, I would second literally everything about the development perspective of rules being to the mature. Something that's also very little talked about is that there's no real good way to like learn ZK. Like ZK is way too young as a field, and like I think it's sort of the main problem for like I guess both of us is that ZK today changes too fast. Right? There's new things coming every day. There's a lot of churn happening, improvements keep happening. I mean that's good because obviously we are getting better stuff, but it also means that the industry doesn't really have like good time to stabilize in sense of picking one technology, building tooling around it, like building pedagogy around it for teaching people how to use it, like how to build your own ZK stack, all this stuff. Right? So yeah, I think personally I'm probably looking forward to ZK stabilizing a bit for the next decade.
Yeah, should have a ZK Academy sometime. Maybe together as we should found a ZK Academy.
Teach me first. I think from our perspective, right, consensus perspective, what we see in the future is Like from Ethereum perspective, we want as many ZK rollup as possible, just to increase the resilience of the Ethereum, right? I think that's what the EF wants, and what everybody wants. Like, you know, if Ethereum protocol fails, it's kind of difficult to be still here. So I think we will continue to contribute to the space. But the other thing I keep thinking was, I think in the world of AI and just no objective truth and just frustration and vagueness, I think ZK is potentially a way out for us to see some clarity.
Yeah, we're talking about like ZK ML, where we can use ZK to prove the fairness of large language models, etc. So I think ZK, the proof power, can be something in the future that everyone will need.
Yeah, a lot of good points there. I think to understand and forecast the like future of zero knowledge, but we kind of have to look at where we started with blockchain. And I think it goes back to like the original Bitcoin paper, where the thing that fascinated computer science researchers so much about it was that it disproved the impossibility theorem, that you couldn't create a fault-tolerant distributed system with such few trust assumptions. And the idea of adding kind of crypto economics to the mix totally revolutionized that. And I think zero knowledge is actually leapfrogging that innovation to some extent, because we're seeing the ability to reach consensus, to do things like validating bridges or workables in ways that you don't need crypto economics, and you can rely solely on zero knowledge proofs. And I think that's a really fascinating innovation and gets us much closer to trustless, verifiable data and compute that's much less volatile than crypto economics.
We hate third parties. So have a saying from the very start of Bitcoin, in math we trust, and that's the beauty of ZK.
From my perspective, and also because we built a product called Manta Pay, so which enable the users to make private transactions, and it worked very well actually. Like a lot of users, they use this product to make private transactions, and for the privacy side, we all know like what anonymous hash like they have faced right now. I believe actually like they will work a lot more than right now for the privacy side. But even right now, privacy is still not like it's very on track or something. Like, but still the big VCs that they're invested the privacy-oriented projects as well. And it just takes time for the people, like, or for the whole industry realize that how important like the privacy is. That will be the first point. So for the roadmap as well, right now we are using like the universal circuits to enable the DApp applications to have some ZK functional things. We will try to still work on the privacy side as well.
Awesome. So imagine one day you can finally receive your payment on chain without exposing your information, definitely. And let's memorize tomato cash as well. Okay, so I think that concludes our panel. If there are any questions from the audience, we're willing to answer them. Yeah, please have really intelligent people here.
Hi, very interesting spaces, by the way. Not spaces, panel. But yeah, I just had a question around interoperability between ZK chains. Do you see a future where there are multiple different ZK chains, and do you ever see it working together in a specific manner? And like, just elaboration on how that would look like.
Yeah, yes. I'll take that first. So, because since we're doing ZK Bridge for interoperability, I feel I'm saying too many times these days for interoperability. So, well, in our future, and also as well as we were talking about the Ethereum future, we will have multiple ZKs on Ethereum for better scalability. And of course, in our perspective, those ZK chains, the layer 2s, even potentially layer 3s, should be able to talk with each other. And how we're going to do that is, well, one thing you can do is ZK Bridge, where the ecosystem we're envisioning is that I know we have different approaches for different chains. We have different types of EVMs. We have ZK rollup. We have optimistic rollup. We have sovereign rollup like Manta. So all those chains have different advantages. Well, as ZK Bridge, we truly believe everyone will succeed no matter which approach you take. It's just different chains have different advantages in different, well, either computational level or application level or just user experience level. So what we want to do is that we want to make the future one day, if you're a developer, you can choose to develop any of the chains for your application. You can even integrate all those different chains within the same application. For example, you want to build a D app where you need multiple parts. You can actually run those multiple parts on different app chains for specialization, for different advantages provided by those app chains. And you can use a ZK Bridge to fully make your system interoperable, make every part of your app connected. And also for users, we help to enable a future where a user can choose any of the chains to start with. Even where we're talking about next billion users for web users, when they come to the space, they can choose any of the chains to start with to have their assets on, to have their account information, have their NFT collection on. But when you need to move to different chains, say I find a new game on another chain, I should be able to seamlessly use my assets on one chain, actually use that asset on a different chain as well, and that can be powered by ZK Bridge. So in our vision, every chain, everything should be interconnected. It's layer 2, layer 1, even web 2 should be interconnected, where you should be able to seamlessly move all your data, all your assets across all those different systems. Hope that answers your question.
Yeah.
I think we have one more. If anybody else have any questions? Are you good? All right, thank you so much to all of our panelists. So can I get you guys to make a photo together, please?
Yeah, of course. I love the panel. I love the composition of our panel. Have different specialization, just like different specializations in layer 2 rollups.
Are you sure you're not MC?
You know, I used to be.
One shot. One shot. Alright, thank you so much to all of our panelists. It's been lovely listening to all of the great insights that you have to share with us. Alright. So Biconomy, Particle Network, Transak, Polyhedra, they all share a common mission, which is to bring Web3 to more Web2 users without the user complexities. So from early this morning, we have had the privilege of learning from some of the brightest minds in the industry. And I hope you leave here today with new insights, valuable connections, very important, and also remain really excited about the future of Web3. So thank you once again for being a part of the InfraCon x GrowthCon event. Safe travels, and I hope that you have a fruitful token at 2049 journey ahead. So thank you so much and have a great evening.